Hi everybody, it's Professor Stevens. I'm going to walk through the R4 set of, well actually these are my classroom notes. These are not the ones that you print out to do along with the textbook, but the ones that I usually do in class. So these will be very similar to the ones that you have in your My Notes printouts. So it starts off with factoring polynomials, factoring out the greatest common factor, factoring by grouping, factoring trinomials, factoring binomials, factoring by substitution. These are all the things that we're going to cover in this section. And some key terms, factoring, which factoring is pretty much just taking apart something that's been multiplied. It's one way of saying it in a simple way. Factored form, prime polynomial, that means one that you can't break down into factors. Factored completely. So sometimes when you first break apart a polynomial, it'll have the new factors that you have, one or more of them could have factors also to be broken down even farther. Then factoring by grouping. Factoring by grouping is actually my favorite because if you get in the habit of factoring by grouping, it works for all the cases of any polynomial that is factorable. So I like to teach it that way from the ground up, and then later as you start to notice some patterns, you can do an easier process, or not easier, but easier in the sense that there are fewer steps involved. But what I find is that students will learn factoring by grouping at the end, when really it should be taught at the beginning. And if you learn it at the end only for certain cases, then by the time you get those cases, most students have forgotten how to do it anyways because they're not practicing it regularly. So my advice is that you practice factoring by grouping with every example. And then if you don't need it on the test, you can do it quicker, great. But if you do need it, you'll already know how to do it. So, all right, so here we go. This first little statement here, factoring out the greatest common factor. Well, the greatest common factor is what you always want to look for first. And it's the process of finding polynomials whose product equals a given polynomial is called factoring. All right, so let's go on to the next one. Class the greatest common factor. Factor out the greatest common factor from each polynomial. Looks like I'm missing part A, or maybe it's just out of order. Yeah, I don't know. I guess I lost it, but that's fine. All right, so here we go. So let's look at each one of the terms here of our polynomial. And this is a polynomial, right? We don't see any exponents that are negative or fractions. We don't see any variables in a denominator of a fraction. So this is a polynomial with three terms. So it's a trinomial in x and y because there's two variables. And it is degree 5 because you add up the exponents of each variable, and the term with the highest degree is the degree of your polynomial. That was all a recap review of what we learned in R3. So from here, now we're going to start breaking apart the terms if we can to see if there's anything in common. And some of you have more experience with this and some of you have less experience with this, or you haven't seen it in a long time. So I'm going to teach it as if it's the first time you're seeing it, whether you actually need all the information or not. That's fine. Okay, so 14x cubed y second power is something you can break down into prime factors like this. 14 is 2 times 7. 2 and 7 are both prime. I'm not going to break down x cubed or y second. And then I have 28, and I'm saying y second, but that really, I could say y squared. I don't know why I'm saying y second. Just one of those things. So then I have a negative 28, which can be broken down into negative 7 times 4. But 4 is not prime. It can be broken down. So that would be negative 7 times 2 times 2. And I'll do them from least to greatest, like this, just as a way to stay organized. And then the next term over here is, I guess I don't need these things. So this one is that, this one is that, And now I'm doing another one. So I have a positive 21 plus 3 times 7. So now we're looking for the greatest common factor. So I'm going to circle all the things that are common to all three terms. So the 2, nope, not common, but since it has to be the greatest common factor, I can't use it. So what is common? 3? No, because these two don't have a 3. Oh, 7. 7 has, 7 is in all three. All right, now what else? I have 3 x's here, 2 x's here, 2 x's here, 2 y's here. So it looks like I have 2 y's in common and 2 x's in common. And then the 7. So if I pull out this common factor that all three all three terms share, rather, I will pull that out front, and I will have this. And then what's left over, I'll put inside parentheses. So this is actually reversed distribution. So we know distribution, if you do something like 4x plus 3, we would distribute the multiplication of 2, and we would end up with 2x squared plus 8x plus 6, right? So this is the reverse of that, bringing that 2 outside of the parentheses. Then what I have left over after pulling out the 7x squared y squared is, let me look at the first term. I have a 2 left over that wasn't pulled out. I have 1x left over and no y's left over. Then the next term, I have 2 2's that I didn't use, so that's -4. And the x squared I already took out, y cubed, okay, so I took out 2 y's, I have 1 y left. Then in the next term, I didn't get to use the 3, I didn't get to pull that out, so then the 2 x's and 2 y's, so everything else has already been pulled out, and that's what's left. So this is actually, and don't forget to put equal signs as you're working down. So that's the final answer right here. Factoring by grouping. So factoring by grouping is usually introduced in examples like this one, which has 2 pairs, or you could look at it as 4 factors, but I always think of it as 2 pairs of terms. Because if you group them up as pairs and then look at what each one has in common, you can pull something out of each pair. And this is only necessary because if you look at all 4 terms, you won't find anything that is consistently common to all of them. So for instance, the S is common here and here, but not in the other 2. The R is common here and here, but not in the other 2. The 5 is common over here, but not in the other 2, and so on. So looking at these as groups, or rather, I could even do it like this. I gotta be careful how I do that because actually it's worth talking about. What I was about to do was to go like this, and that is not correct. It is also not correct to do like this because then that looks like multiplication, and that's not what we're doing. What would actually be better is to rewrite this one. It's because of this negative, it's complicating things. If I put the parentheses here, it indicates that you would distribute the negative, and then you would actually have negative 5s plus 15, which is not the case. So we want to be careful with that. So I'm going to rewrite the first line as r squared s plus 3r squared, and then plus negative 5s minus 15. Then Hi, sweetheart.
I have a drink of water.
Yes,
It's
sweetheart.
water. We worked hard with bushes.
Aw, very nice.
And took a ride around the block, stopping and said hi to Cole.
Aw, nice. You like saying hi to Cole. What are you guys doing now?
Oh, we were just got back from off stuff.
Okay. You ready for a bath? No?
Get a cool drink, and I guess maybe we'll weed whack your yard, huh? The play yard.
You gonna go help Grandpa some more?
Mhm.
Oh,
You want to weed
nice.
whack and clean up the play yard?
And then help.
Okay.
Yay.
Is that your drink?
You can bring it with you, honey. You can put ice in that too if you want.
Get some ice. Put in your drink.
Yeah.
Okay, sorry guys. A cute little boy just interrupted. So where was I? The r squared s plus 3r squared. What I can take out that's common is the r squared term. And what's left is s plus 3. And then from the other set, I can take out a -5. And at this point, I don't need this plus anymore once I do that. And since I pulled out a -5, I have what? A -3? But since I pulled out the negative, actually I have to make this positive now. Okay, great. So when we get to this point, the way you know if you did it right is if you have that set of parentheses identical. If it is not, there's two possibilities. And the most likely possibility is that you made a mistake. So for instance, if I had done this, then you'd see that they don't match. The two sets of parentheses are different. So that would tip me off that, oopsie, I should have made this a positive because I already pulled this negative out here, right? The other thing that could happen if they don't match, the other reason could be that it's very possible that this is not even going to be factorable no matter what. Like there isn't something, because in a sense what we're doing is we're trying to find a set of parentheses that is in fact a common factor to these two groups. Like if you think of this as one factor and this as one factor, then s plus 3 as a quantity is the common factor of those two terms. So let me say that again. When I do this step of rewriting as r squared s plus 3r, grouping them like this, 3r squared, putting the parentheses around them, I'm trying to make them a single term. I'm trying to take two terms and make them into a single term in a sense.
Mommy?
Yes, sweetie?
Grandpa said my diamond is Grandpa's.
He's just teasing you, honey. You know it's yours. He gave it to you, babe. All right, so he said to Grandpa, I told on you. All right, so I have, where was I? I was talking about how I'm trying to take these two terms and make them into a single term as a group. These two terms and make them into a single term as a group. Remember, terms are separated by pluses and minus signs. Factors are separated by multiplication. So when I take what is common out of each individual grouped factor, at this point, I can say that this is my GCF. S plus 3 is my GCF. Because now I have, another way to see this is now a factor, right? And this is a factor, right? So you have r squared times the quantity s plus 3. So that is, there's multiplication happening between them, which means that r squared and quantity s plus 3 are not two separate factors, but they're a single term. Wait, I said that wrong. What I meant to say is that r squared and the quantity s plus 3 are not separate terms. They are a single term attached together by multiplication. So they are factors. They are this little collection here, this expression is actually a product of r squared and s plus 3, but it creates a single term. Just like this is a single term here. So now that I'm looking at this as a term and this as a term, I'm looking to see if they have a common factor, and s plus 3 is what's common there, and whatever's left over, as usual, goes into a set of parentheses. And this is the factored form of this polynomial. All right, now, it's important to check, especially for newbies, and even if you think you've got this down pat, you should be checking, because nobody did well on that test. So all of you need extra practice. Okay, so now writing this out, my answer I had over here, I'm looking to see if when I perform the multiplication, if I end up with r squared s plus 3r squared minus 5s minus 15, right? That's the question. So I'm going to perform this multiplication. So I'm going to do s times r squared. S times negative 5 is negative 5s plus 3r squared and minus 15. Alrighty, let's check. Is that the same thing as what I had over here on the right? Okay, so let's first look at the first term here. So I have s and r squared. Here I have r squared s, and we all know that multiplication is commutative. In other words, 2 times 3 equals 3 times 2. And so I have one term down that's correct. Next one, negative 5s, negative 5s. All right, let's look at positive 3r squared, positive 3r squared. And finally, negative 15, negative 15. So it does work out as I would expect it to. All right, so I'm going to have to erase this to be able to do part B. And I don't want to, but I guess I can take a picture of this. Or maybe what I'll do, that didn't work. So maybe what I'll do is I'll stop this and start a new one. All right, guys, see you on the other side.